tell you that today we're going to finish theme 1, which is the univariate and bivariate data sets. We're going to actually finish theme 2. Theme 2 is very short, sweet, and to the point. It's all about experimental design, surveys, all that vocabulary, and we're just going to do a little clicker activity with that today in class. And then we're going to jump into theme 3, which is probability. Probability is going to be a tough unit. If you remember, we did that back around Christmas break, winter break, and it was not an easy unit, and it's been a while since we've done it. So I'd like to spend at least 2 full class periods on probability. On Friday, you'll have some problems to do for homework tonight for Friday. We will do a FRQ on Friday that deals with probability, and then we'll look at some of those formulas. Remember all those formulas on whether they're dependent, independent, addition rule, multiplication rule, conditional probabilities. So we'll come back to that. And I know it's been a while, so it's not a good day to miss. So if you're going to be here Friday and be here next Tuesday, because those are the meat of our review. All right, I'm just going to go ahead and give you the answers to these questions here from the homework on theme 1. So let's do that first. And this particular question was the first one on bivariate data. Again, those little dots are supposed to be A, B's, and C's. It just has to do with whether it was pulled in. I think on every other review that they've been fixed, but the last one here is E. Okay, the last question. Okay, that's the slope in terms of in context. So make sure that you're looking at that. Okay, for every is the words that describe slope, because slope is written as a fraction, as a ratio. So it's whatever is the bottom half of the fraction. For every 1 blah, 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 this happens. Okay? All right, next question. We're looking at the scatter plot. Notice that the y hat is something I added. I don't believe that it's written there. Tell me if yours is or not. Is it? The hat's there? Okay, good. Sorry, I'm looking here. On mine. Huh. I have a lot of empty questions here. Is this one of your questions? Sorry, this is, I skipped over the question in my answers. This question deals with straightening out the data. If you remember, if you have a data that happens to be curved in any way, you can take the log of one or both variables and possibly straighten it out. It could be an exponential degree, it could be an exponential equation, a logarithmic. It tells us here that it indicates an possible exponential. So you have to know when it's exponential, what do you do to straighten out the data? I think we can unlock it now. Okay, so here's our regression align. Which of the following are valid conclusions? The answer is the predicted revenue is approximately $59 million. It is Roman numeral 2 only. It has to do with whether or not you're taking the log of both or one side. This one is kind of one of those questions that I hate to say I'm not going to spend a lot of time on because it's not going to be on your exam. Okay, I shouldn't say it's not. The likelihood of it being on your exam is very, very small. Okay, it's just not worth it. So, I mean, I can show you really quick if you're interested. Because we're looking at, what does it say, 5? Oh, from 2005 to 2000, right, is 5 years. Sorry, looking at that. Plus 0.67 is 4.77. Okay, that's just if you plugged it into the equation. 4.77 is even not listed, so we don't even know what to use for that. But I can tell you that because we know that log base 10 of x equals y, 10 to the y is equal to x. So 10 to the 4.77 is the answer, which is $59 million. Again, don't worry too much about it. It has to do with whether you're taking the log of x. Okay, take the log of x, it becomes exponential. That's all. Okay. All right, let's keep going. Residuals and outliers are probably something we need to make sure we understand. So here we have outliers in the y direction have large residuals. Is that true? A point may or may not be an outlier. You can read here. But the first two are correct. Okay? Why is that? Removal of an influential point. Remember the difference between an influential point and an outlier? Influential points are going to move the slope of the line, where outliers are maybe in the trend. They just happen to be further away in a y direction. I'm sorry, an x direction. So, for example, the red dot could be an outlier. Would you agree? Okay? It's not going to affect the slope of the line very much if I take it out. However, isn't that going to sharply increase it? The red dot is here is called an influential point. Would you agree? A little different. So that's why this is not the correct answer. Okay, residuals. This is a good question to know. All of them are true. Okay? The mean of the residuals is 0. If you remember when we did our scatter plot investigative task, I did ask for you to find the sum of the residuals, and the mean is also going to be 0. The regression line for residual plot is a horizontal line, and that's not something I think I emphasized, but it's true. If you have a residual plot and it's random, which it should be, some are above the line, some are below the line, it's random, isn't the regression for that just going to be a flat line? There's not going to be a line, right? I mean, it's not going to be a slope of any kind. It's going to be a horizontal line. A definite pattern in the residual plot indicates that a non-linear model is right, and that's true. Okay, if you have a patterned residual, it means that it's either quadratic or exponential or logarithmic or something other than a line. So all three of those are actually correct. Okay? All right. SAT scores. This one, the answer is 39.9%. This one was kind of an easy. You're looking for percentage of variation in GPAs. That simply means R squared. A percentage of variation that's explained by, isn't that the words I use to interpret R squared? So you're simply going to take 0.632 and you're just going to square it. And by doing that, you get 39.9%, or 0.399. Okay? Doing good so far? Anyone get them all right so far? Okay. Especially with that one log one. By the way, I thought this is an Algebra 1 question. Believe it or not. Okay? But it's been a while since we've done it. So the answer is no value can make the correlation 1. The answer is the last question. Okay? There are multiple ways to do this question because there's multiple ways to determine whether something is linear or not when you have a set of points. You can graph it. You can look at the patterns between the x and y values. I'm not sure what your Algebra 1 teacher taught you so many moons ago. If I were going to graph it, which is probably where I would start, we're going to graph the point 0.25. We'll graph the point 0.37. We'll graph the point 0.49. Those look extremely linear to me, don't they to you? Okay? If you look at the x values, they're increasing by 1, and the y values are increasing by 2. They are linear. Okay? The slope is 2 over 1. Remember this sound familiar back from many moons ago? This is the problem. When I graph the point 512, it no longer has that same pattern. The x is still increased by 1, but what happened to the y values? It increased by 3. So it's going to be like up here, where these are perfectly linear. Isn't that point going to be above the line? So the correlation can't be perfect. Isn't R equals 1 a perfect correlation? Every single point should be on the line. but 0.512 messes that up. Okay? There's nothing that could work for n to make it happen. Any questions about that one? I thought that was a good question. The way it was asked was a little bit interesting, but again, algebra 1 question. Okay, we did this one. We started it during Flex today. We had to, this is the kind of background. Let's make sure we understand, how do I find the correlation coefficient? Look at your information that was given to us on the previous page here. And how do I find R? How do I find the correlation? Matthew? Exactly. We're given R squared here, 0.746. So we're simply going to take the square root of 0.746, and you should get 0.864. Okay? What kind of units does a correlation have? None. Very good. Good to remember that. It's unitless. Okay? So you're not going to put, you know, anything about the grade or the length of the paper or anything like that here. The slope of the regression line, if we're looking at question B here, which number up here represents the slope? Right. So 1.106, so this is the slope of the line. So if we're going to use 1.106, I'm going to put that number over 1, because as I describe it in a sentence in context, I need to say for every blah, blah, blah. So what are my units for slope? If you remember, it's y over x. What are my y units? The grade. If you look back here, this here with the hat over it, it's always your y, isn't it? So the grade is your numerator, and the length is your denominator. So this is going to be grade over length. So let's say a sentence here that puts all of that together. For every one additional page that you write, your grade is going to increase by 1.106. And that's the sentence you write. And that's all you have to say. Okay? Your hint when you talk about interpreting slope is you need to say the words for every, okay? And you're going to, for every, whatever number's in the bottom, the denominator, explain what happens in the numerator. So for every additional page, the grade increases by 1.106. How will the correlation coefficient, so how will R, which is 0.864, how will it change if Mary's paper was included? Is it going to stay the same? We're going to use strength words. Is it going to increase or decrease? Is it going to become stronger or weaker? What do you think? It's going to decrease. Why? Right, so her grade is not in the trend line. It's different than everybody else's, so it's going to decrease the correlation. So the correlation will decrease. Okay? How about the slope? Think back to if I was going to draw this. We have people's papers, and then we have Mary, right? She's down here. Her grade's out of the trend line. What's going to happen to the slope? Again, use the words properly. What kind of descripting words are we going to use? Okay, the slope will decrease. When we talk about slope, we want to talk about its steepness. So will the slope become more steep, or will it become less steep? Less steep. So it will also decrease, but it will become less steep. Good. What grade did Mary receive? If you remember, we had to add some information that Mary's paper was 25 pages long. So we need to be able to answer the last question, plug in 25 into here. And I think I mentioned this during Flex, but I'll say it again. 2 years ago, when I was in Kansas City grading the exams in June, One of the questions I was grading, the rubric was a question very similar to this. When it says the word predict, which it does here, predict, it means to use the line of best fit, which means they want to see you actually physically write this. Show the work. And then tell me what the answer is. So I think I got 74.16, which on our grading scale would be a C. Just depends on where you are. Have you guys always been around for 10-point grading scale? No. I'm old. It used to be 93 and above was an A. 92 was a B+. Back in old school. And a 65 was the lowest D you could get. A 64 was an F. Back in the day. It was weird. Anyway, we went to 10, so I wasn't sure when that happened for you guys. Okay. Last question, our last couple of questions. We talked about this during Flex as well. Let's just make sure we did it correctly. Marginal distributions means you're working in the margins. So you need to find the margins. We have 600 men, we have 200 women, for a total of 800 people. You have 190 that are against this bond issue, and we have 610 that are for it. When it asks for a marginal distribution, we're looking at which category. Are we talking about gender, or are we talking about, we can look at both marginal distributions. Excuse me. If I wanted to look at the marginal distribution for gender, I'm going to have to say, okay, men is going to be 450, I'm a liar, is 600 out of 200, whatever number that happened, out of 800, sorry, looking at the wrong number. 600 out of 800, you always divide by your total when you're talking about marginal distributions. And you can reduce that to 0.75 or 3/4 or whatever, it's fine. Okay? I tell you what, guys, I'm saying the right thing, I'm writing the wrong thing. All right, and then we have females, because we also have females in the gender category, and we're going to say 200 out of 800, which is just 0.25. So that is the marginal distribution just for gender. You could do the same thing for their opinion on this particular bond issue as well. Okay, marginal distributions divide by your total. If we're talking about conditional distributions, we're actually using the inside of the table. So we would have a conditional distribution for men, for example. So we'll do just men. So that's going to be 400, I'm sorry, I wrote 450. 450 out of 600 are going to be for, and 150 out of 600 are going to be against. And you could reduce those. And there's more we could write, but I just want to give you an idea of what you divide by versus for each one. Okay? Any questions about that? It's been a while since we've done that. All right. This question intrigued me at how many people did it differently. In order for it to have perfect independence, that simply means that the ratios are equivalent. Which ratios are there? Well, lots of them could be true. This is how I did it, which is silly now when I think about it. But I summed everything, and I said, okay, this total is 50, and this is 50 plus n. And then I used those. I could have gone the other way. This is 70, and this is 30 plus n. And then I just did some, that's silly. That's not necessary, okay? Let me show you the easiest way, is if you just say, well, this has to be the same as this. And you just cross multiply. And many of you did that. Showed me up, okay? I love Anna. Anna did 20 out of 50 is 30 over n. Perfectly okay. That also gives you the same answer. Did you do that, Anna? Okay, I thought you did, yeah. Perfectly okay, gives you the same thing, right? Doesn't matter. There's lots of ways to write the proportion, but perfect independence means that you're doing this, okay? And that's it. So you're just going to cross multiply, and the answer is 75. All right. I'm going to pause the recording here because we're going to do something as a class that doesn't need to be recorded. So hopefully you've read question 23. It does. What are some key words in that question? Why am I recording this? I told myself I wasn't going to record this. Sorry.